Hello Kimani, welcome to our video lesson for today. I hope you're well, and it does feel a bit like a Wednesday now that we're back in some type of teaching routine, but I hope you're coping at any rate with all the Skype calls, videos and worksheets that's flying your way. So in the first video I'm going to be covering a little bit on the graph hyperbola. This will just be like a little intro, and in the second video I'll be doing the solutions for the homework that I sent out on the 11th of May. So if you hadn't done the homework, hopefully this hyperbolas section will help clarify the story on the vertical asymptotes, and then you can attempt the homework and watch the solutions at a later date. So to start off unpacking this graph, hyperbola, you'll find it on page 128 of the textbook. We'll use the same methodology as we did when unpacking parabolas. We'll start off with the simplest case and then we'll adjust things. We'll see how the parameters change, how it influences the overall shape of the graph. So just a little description of hyperbola. You might have encountered the term hyperbole in English, which is exaggeration. So if you look at a picture of this graph, you'll see that it's got two elongated C branches, and each branch goes to infinity. Infinity at the top and infinity vertically, infinity horizontally. So it's like exaggerated. So our simplest graph that we're going to start off with is y equals 1 over x. So I'm going to make up some x values and plot it, show you a little bit how this equation works. X, -2, -1, -1/2. X values are 1 and 2. So notice I can't let x be 0, because then we get 1 divided by 0, which is undefined. So my negative values are here and my positive values are here, and there's no 0 in between. So for the first point, x equals -2, we substitute it into the equation and we'll get -1/2. Substitute -1, 1 divided by -1 is -1. And let's look at this one quickly, 1 divided by -1/2. So this might bring back memories of grade 7 with the tip and times rule. So we'll do 1 divided by -1/2, which is 1 over 1 divided by -1/2. So I've converted it from a whole number to a fraction. So now we can use our rule, tip and times, fraction divided by fraction. We tip the second one and we times it. We times the tops together, 1 times 2 is 2, times the bottoms together, 1 times 1 is 1, and our sign is negative, so overall we get -2. Okay, same story for our positive values. 1 divided by 1/2 is 2, 1 divided by 1 is 1, 1 divided by 2 is 1/2. Let me plot it really quickly. -2, -1, 1, 2, 1, 2. This is y, this is x, -1, -2. So -2, -1/2, -1, -2, -1/2, that's underneath, -1, -1, and -1/2, -2. Our lower branch looks like this, and then we have 1 and 1, 2 and 1/2, and 1/2 and 2. So our upper branch looks like that. So now let's talk a little bit about what's happening as the graph nears the vertical axis and as the graph nears the horizontal axis. We can see for the vertical axis, as x gets closer and closer to 0 from the right-hand side. So if x was 1 and it's getting closer to 0 from the right-hand side, it will get into a fraction, it will get smaller and smaller. So as it gets closer to 0, it becomes a half, then a third, then a quarter, then a tenth, then 1 over 100. X is getting closer to 0 from the right-hand side. So what is happening to y? Y is getting bigger and bigger. In fact, when x equals 0, y should be like infinite in size. So that's undefined. So let's see how this works. So let's substitute these x values into the graph. So for y, we'll get 1 over 1, which is 1. 1 divided by a half is 2. 1 divided by a third is 3. 4, 10, 100. So as x is getting closer to 0 from the right-hand side, y is just getting bigger and bigger. So that explains this, this shape over here. Okay, from the other side, as x is getting closer and closer to 0 from the left-hand side, that means x was less than 0, so some negative number, and as it's getting closer, it becomes a smaller and smaller negative fraction. So negative a third, negative a quarter, negative 1 over 100. Let's see what happens to the y value. Well, it's exactly the same, it's just that our sign becomes negative. So it's negative 1, negative 2, negative 3, negative 4, negative 100. So y becomes a very big negative number as we get closer to 0 from the left-hand side. So whenever a graph does this, whenever a graph tends towards a certain value but never quite reaches it, it's called an asymptote. So in this case, the y-axis is our vertical asymptote. We can also see another horizontal asymptote for the x-axis, where the graph looks like it's getting closer and closer to 0. The y value is getting closer and closer to 0, but never quite reaching it. So we've described our vertical asymptote as the y-axis, and we've used some numbers to show this. Now let's look at the horizontal asymptote, the x-axis. Okay, so let's see what's happening. As we're getting further and further along the x-axis, it means our x value is getting bigger and bigger. So if we start off with an x value of 1, let's make it bigger and bigger, 2, 4, 8, 100. What happens to y? When we substitute these points, it's 1 over 1, which is 1. Then it's 1 over 2, 1 over 4, 1 over 8, 1 over 100. So our y value is a fraction, and the fraction becomes smaller and smaller, getting closer to 0. Okay, so let's look at what happens on the other side. As we move this way along the x-axis, it means our x value is getting more and more negative, a bigger negative number. So x is negative 1 over there, and then it moves negative 2, negative 4, negative 8, negative 100. Let's see what happens to the y value. So it's the same as over here, it's just that our sign changes. Negative 1, negative half, negative quarter, negative 8, negative 1 over 100. So our y value, it's getting bigger. You see, negative a half is bigger than negative 1. Negative a quarter is bigger than negative a half. So it's getting bigger, but it's never quite reaching 0. So that describes our two asymptotes, the vertical and the horizontal. Now let's look at the effect of some of the parameters on the shape of this graph. So in the textbook, the general equation is given as y equals to a over x plus q. Okay, for the first worked example on page 128, they are just focusing on the parameter a. So we have our general graph, y equals 1 over x. Next graph, y equals 6 over x. And y equals 12 over x. So we're making a bigger in each case. We're just leaving q in each of these graphs as 0. Y equals 1 over x plus 0, q equals 0. So they give us a table of points for the x values, minus 6, minus 2, 1, 2, 3, 6. And they just plug these points into the formula for each of the three graphs. And you can see that the effect on the overall shape from this picture is that as a gets bigger, our graph bends more outwards. So as a gets smaller, it gets like more compressed. As a gets bigger, it widens out there. Okay, so that describes our parameter a. Now let's look at the parameter q. So the parameter q works in a similar fashion to how q worked when we looked at parabolas. Remember, when we changed q in parabolas, we moved the graph up and down, and the same thing is going to happen here. Let's look at an example. So our general case was y equals 1 over x, and in the worked example we look at the graph y equals 1 over x plus 1. Okay, let's make a list of points, refresh, or let's rather use their points if they have any. No, they don't. So minus 2, minus 1, minus a half, half, 1, 2. Our y values, oh wait, for the first graph, our y values are 1 over x, 1 over x, and the second graph is 1 over x plus 1. So our y value here is negative a half, negative 1, negative 2, 2, 1, half. And our y values for the second graph are going to be exactly the same as the y values in the first graph, but we're just adding 1. So it's 1 over x plus 1. So we can just add 1 to each of these. So that would be 1, 0, minus 1, 3, 2, and 1 and a half. Okay, so if we plot this, minus 2, minus 1, 1, 2, 1, 2, let me make it a bit bigger to include 3, because we have a y value of 3, then minus 1, minus 1, minus 2. So let's plot this quickly. So from the first graph we have minus 2, minus half, minus 1, and a half, minus 2. Next graph, a half, 2, 1, 1, 2, half. Looks like this. And we expect that when our q is plus 1, that this whole graph moves 1 up. All our y values get 1 bigger. So for the first value, x equals minus 2, y equals a half, minus 1, 0, and minus a half, minus 1. So it looks like this. And our upper branch, it's half, 3, 1, 2, and 2, 1 and a half. So our upper branch looks like this. So let me actually just use crosses to try and show so it's not that confusing. So our original graph is here, and the graph with the crosses, everything has moved one up, okay, including the asymptote, including the horizontal asymptote. So in our original graph, the horizontal asymptote was the line y equals 0. In the shifted graph, our horizontal asymptote has also moved one up and is now at y equals 1. Okay, next they talk about axes of symmetry. So an axis of symmetry is like where we could fold the paper and the one part of the graph would overlap with the other part perfectly. So let's explain that with our original graph, y equals 1 over x. Let me redraw it. Minus 2, minus 1, 1, 2, 1, 2, minus 2. So it's minus 2 half, minus 1, 1, minus a half 2. Looks like this. Half 2, 1, 1, 2 half. Okay, so the axes of symmetry would be this line over here and this line over here. So sorry, this line is drawn a bit badly. It must pass through 1, 1. Okay, so that looks a bit better. So if you folded the page across this line, this branch would overlap to the upper branch. If you folded the page along this line, this half of the branch would overlap there, and this branch would overlap there. So these are the two axes of symmetry. So what about in the case when the graph is shifted? So in this case, our axes of symmetry also shift. And it's only the value of q that affects the shift. The value of a doesn't really affect the value of the axes of symmetry. So if we're looking for the equations, this line here, because it passes through 1, 1, 0, 0, and minus 1, minus 1, it would be the line y equals x. This line over here, by similar reasoning, equals, or as the equation y equals minus x. So if we have a graph y equals, in the worked example, y equals 4 over x minus 2, our axis of symmetry is going to be the same as our original graph, just minus 2. Symmetry y equals x minus 2. And for the other graph, it's going to be y equals minus x minus 2. Let's just double check that. Symmetry y equals x minus 2, y equals minus x minus 2. So this just summarizes all the parameters and all the other properties of this hyperbola graph. In the next video, I'll be doing the homework solutions for the homework on the 11th.